Hi, everyone. So I think there's been a lot of good topics today, and I think a lot of sort of overlapping. If you drew a big Venn diagram, we're sort of all sort of hovering around the cloud, its applicability to the workflows that we're talking about here. What I'm going to actually talk about today is a little bit more on what happens to the stuff I produced yesterday, so more around the archiving and preservation of digital data. So ultimately, when we're talking about massive scale non-transactional asset workflows, I'm not talking about, obviously, there's been a lot of presentations on GPU rendering and doing processing and distribution in the cloud, but ultimately we're talking about essentially data at rest here. So when we look at these types of workflows, we're looking at challenges. Obviously the scale of data. We're not talking about half a petabyte or a petabyte or 5 petabytes of data. This might be dozens of petabytes, if not hundreds of petabytes of data. You look at all of the assets of an organization like Disney, for example, through all of history. You're talking about hundreds of petabytes of data. The devices and workflow integrations, I think one of the things that we tend to maybe gloss over just a little bit are all those nice little lines between the blobs that we show in our presentations here. Ultimately, it comes down to the device. When I click on my Avid editor or my Final Cut or my rendering farm engines or whatever else, do I have access to the data? Security, pervasive topic, of course, whether you're dealing with assets in the cloud or whether you're dealing with them on-prem. Search and accessibility, a couple presenters have touched on that today as well. Vendor lock-in, a big one. Obviously, there's the heavy lift into the cloud and potentially a heavy lift out of the cloud. And I think the gentleman from Pac-12 just talked about that as well. What do you do if you're not exactly happy with your long-term solution provider? Is there a way to actually migrate this data? When you're talking about large scale, you move your photographs into iCloud, you don't like them, you move them over to Google Photos, it's an easy transaction. But when you're talking about hundreds of petabytes of data, it's a little bit more of an issue. Cost, nobody, or I guess some people have talked about cost, but obviously this is one of the major motivators or one of the major things that we're going to look at in characteristics. And our objectives: flexible, long-term massive storage, OAS compliant preservation. This is something that's very important in the preservation communities. Metadata, encapsulation, enrichment, metadata mining, topics like that, machine learning, AI, and things like that. Can I learn more about my data over time? Disaster recovery and business continuance from an operationals perspective tends to be or want to be object-based. We don't know what these sort of data structures are going to look like for all of the new VR and AR stuff coming out. IMF, previous presenter just talked about that as well. We want technology independence, so we don't need to necessarily want nor care about different types of technologies, operating systems, platforms. We want it to be independent when we're talking about our sort of crown jewels of an organization. And then, as much as possible, open standards based, of course, as well. So just a little step back to storage technologies. I know we tend to sort of forget about the stuff that's behind the curtains inside of all these data center providers and cloud providers. But if we look back in 1999, what 10 terabytes looked like, it was Storage Tech Powderhorn, just an idea of scale there. Just over 6,000 slots with Timberline tape drives. And I actually looked it up, and you can still buy media for this thing, about $32,000 for 10 terabytes of data. Our mobile phones are approaching that much data today. So if we fast forward about 18 years, back in 2014, 2015, 2016, there was releases of some new technologies, specifically the IBM TS1150 and the Oracle T10KD, ultimately about 10 terabytes per cartridge. So you look at this from 6,200 cartridges down to about 1. Obviously, orders of magnitude more resilient, more robust, faster, obviously, and significantly less expensive, about $280 street price for the same 10 terabytes that you're talking about. And that Powderhorn might have cost millions of dollars back in the day. And then if we sort of fast forward, assuming there's going to be some exponential growth and increase in the accelerative development of this type of technology, what does 53 petabytes look like in a half time frame coming forward? Well, it might look like that. DNA, you've all sort of probably read articles. There's a lot of organizations doing work and research. There's been some successful POCs on this, one actually by Technicolor as well. Huge amounts of density, huge technology advantages, some challenges to bring that to market, but who knows what it'll be tomorrow ultimately. So the point here is that you really don't need to care specifically what the storage technology is. Obviously you want it to match your resiliency characteristics, your cost profiles. But if it happens to be Gophers chipping data into stone tablets and it happens to meet your SLAs and your cost objectives, why do you care, right? One thing we don't typically care enough about, and actually Eric gave me a little bit of a plug before, is how we store the data on these technologies. So regardless of whether it's this 10 terabytes back in 1998 or upcoming in 9 years, DNA-based storage, ultimately this is where the SMPTE AXF, the Archive Exchange Format standard, comes into play. Ultimately, it's a universal standard for wrapping, encapsulation, storage, transport, and preservation of file-based assets. If you think about it just like an advanced zip file, ultimately it's a container where you throw in a bunch of files of any type, of any format, limitless scale, et cetera, et cetera. You throw in a bunch of metadata, descriptive information, catalogs similar to what you would see in an IMF environment, and a universal file system as well that helps you abstract the underlying storage technologies. Essentially, that's what AXF is. It applies to any file types of any scale, any storage technology. It's OS, file system independent, et cetera, et cetera. And it's very unique standard that sort of transcends all of the discussions that we've talked today. So whether you're in a current production and you're moving assets between your cloud data center providers, or you're looking at a long-term storage objective with preservation characteristics, AXF could meet those needs. Pictorially speaking, this is ultimately what it essentially boils down to. You have a bunch of metadata, whether they're standard metadata packages or structured or unstructured or proprietary. Some payload files, ancillary files. Those don't have to be media objects. They could be Word files, database captures, photographic images, audio tracks, et cetera, et cetera. Could be an entire IMF construct stored inside of this AXF package as well. We layer in preservation elements. This comes back to that OAIS preservation standard that I talked about before. Essentially, it's a reference architecture. We layer in a universal storage agnostic file system, a very simplistic file system inside of this data object. And essentially, all of those come together to form an AXF object. I won't go into it in too much more depth, but if you're interested, there's a community portal, openaxf.org. There's some information there, high-level overviews of what AXF is and why it might be important. One of the important things to note here is ultimately it's already deployed and in use, storing and protecting hundreds of petabytes of data across verticals, including broadcast, national museums, national archives, museums, sporting organizations, law enforcement, intelligence communities as well. So it transcends what we're doing just in media and entertainment, and really has become applicable to a lot of other challenges that some of these other verticals are facing as well. Okay, so now getting back to the first part of my presentation where I presented this idea of the data at scale challenge. So here's just a little chart, and remembering back to when life was easy back in the SD days. But essentially, these are some of the formats that might be in use today that you might be familiar with in terms of production. We can hone in on the bottom one, and arguably you can modify the frame rate and the frame size, et cetera, et cetera. But ultimately, just looking at uncompressed 4K down at the bottom, at 24 frames per second, you're looking at about 5 terabytes per hour of content. So this is not, again, your home video or home photo collection. These are really large assets. And I'm going to take these numbers through a bunch of different calculations here, but ultimately just picking that sort of as a baseline reference. And then, of course, you take that 5 terabytes, and you add on high frame rate, HDR, high dynamic range, 8K. All of these things are here today or will be here very soon. So this data challenge obviously scales up accordingly. And for each, as was mentioned by a previous speaker, for every 5 terabytes of finished assets, there might be a 10x multiple of production assets that might be important to hold on to for the long term. So one thing I tried to do here was I took a picture of all of the current, let's say, more traditional storage technologies, so ranging from optical, LTO-67, T10KD, and the TS1150. And these are essentially the transfer time, so how fast can they move data in and out of those environments. And what I did was I actually normalized by multiples of real time. So again, if we're just looking down at the bottom here, again, we'll use this as our standard measure here, uncompressed 4K. The green, orange, and red notations essentially mean greater than or slower than real time. So essentially green means that many multiples faster than real time, and red means that many multiples slower than real time, and the orange in the middle is right around real time-ish. So you'll see that actually an uncompressed asset, even with some of the fastest tape technologies out today, the TS1150, the T10K, and LTO7, are still 5 or 6 times slower than real time. So that means to transfer an uncompressed 4K asset, it's going to take you 5 hours for 1 hour of actual content. So it's a staggering amount of data that we're talking about here, and I just really wanted to put that into some relative perspective for you as well. And again, back in the SD days, had we technology today, and we'd be really laughing, but consumers wouldn't be happy. So now what I've done is I've taken that to 1,000 hours. I just recently read an article saying that, or talking about Netflix doing 1,000 hours of original production content creation this year. So I took the 1,000 hours now and scaled that up. So now when you're talking about these discrete storage technologies, data tapes essentially, or optical disks, these are how many pieces of media of each of the particular flavors you'll need to store the appropriate resolution of data. So again, each of the storage technologies range from 300 gigabytes per next-gen Blu-ray optical disc, all the way up to the largest density today, which is 10 terabytes. And this is right around where shingled magnetic recording hard drives are too, so you can sort of map out the same kind of numbers here, minus all the error correction and coding. But essentially, you're looking at, for uncompressed 4K, again, 1,000 hours of content, you're looking at about 500 or 600 independent pieces of media. It's not an insurmountable thing. That's about a medium-sized robot today, maybe something about half the size of a refrigerator. You want to make 2 copies of that, so now it's double that type of media. But you'll see that it actually points to some of the viability of some of those different storage technologies. Obviously, managing over 2,000 LTO6 tapes is much more of a problem than managing 500 or 600 T10K or TS1150 tape drives, or tapes in those environments. Now, when we take that and we map it out to cost, what does that cost? So these are just street price. I just looked these up earlier today. Essentially broke them down to cost per gigabyte, because that's a very familiar metric that we use today. Ranges from about 8 cents per gigabyte for Blu-ray down to about, actually interestingly enough, LTO6 is the cheapest tape storage technology, again, because it's the last generation. You're paying less of a premium than LTO7 today, obviously. But there's some other trade-offs. Obviously, it's half the speed, so you need more tape drives. You need more slot licensing. So this is a oversimplification of the challenges you might face, but I have a slide that points to some of that. So if you look at the numbers, again, up at the top, I broke it down per gigabyte, not per gigabyte per month, per gigabyte. And this is essentially what list price would be on, or street price, sorry, would be for the number of media that you'd need to actually store that 1,000 hours of data in those environments. So look seemingly to be a little bit scary, the numbers, but this is all CapEx, and I put an asterisk beside it because that tends to be a dirty word these days. Everybody wants OpEx, or thinks they want OpEx. CapEx, this is a capital investment. It's a one-time expense. It's not a per month or anything like that. So there's an asterisk beside that because every 5 years you might need to buy the latest and greatest storage technology and go through a migration process. But if we sort of follow that curve of storage technology advancement, the next time you buy this storage technology for the same amount of data storage, it might be half or less the price. So there's sort of a diminishing curve of those storage migrations to new technologies. And then control with an asterisk beside it. Control because this stuff lives in your environments, in your data centers, you touch and feel, you put in your own security measures, and you enclose it all. And whether that's a good thing or a bad thing, depending on which organization you work for, it does ultimately give you control over your assets and control over your own destiny, I guess, as you go forward. But you've seen a lot of people talk today about not wanting to build up data centers, not wanting to build out infrastructures. But I think what I'll jump ahead to the conclusion at the end is it's not a mutually exclusive decision that you can make. You can actually make an and decision as opposed to an or decision, and I'll tell you why. So when you look at the on-prem total cost of ownership, obviously just the raw storage costs, all those numbers that I just threw up there, they don't tell the whole story. So there's infrastructure costs, storage, other bits and pieces and tidbits where your operating systems are stored, and the cabinets to put those data tapes in, and drives and whatnot. There's recurring costs like your staff, your IT specialists, your network guys, the people that know how to plug in fiber channel networks and things like that. Technology refreshes, storage migration, upgrades, support and service contracts. But the bottom thing I think is one I'm going to focus in on a little bit, this idea of CSM, or content storage management. And I think this is an important characteristic, an important concept for me to cover today. So what is content storage management? Ultimately, content storage management is software-defined active archive tiered storage software. So you think about it as an application layer that sits above any type and any amount of storage technologies, regardless of where it's deployed, all of those different things, even dating back to that powder horn technology. And it abstracts and gives you a bunch of open APIs that let you access your data, but ultimately manages all the complexities of that storage technology behind the scenes. Integrates with any type and any amount of storage, disk, optical, tape, cloud, etc. Something different next year or the year after, you never know. It's object-based, so this is a key concept today as well, where you're hearing, regardless of what the storage solution provider is, object-based is an important concept that we leverage. Secure, protected, authenticated with full chain of custody. So chain of custody is important when you're talking about productions and things like that. It's very important when you're talking about evidentiary data, when we're dealing with law enforcement agencies and things like that. Essentially, we can show an exact path of that data from when it was conceived of or instantiated through its entire life cycle, regardless of whether it's stored on data tape, on DNA storage in the cloud, it's been transferred back or forth. What barcode of which data tape drive, what firmware, what OS, what geolocation data. All of that information is persisted forever inside those objects themselves. That's actually a characteristic of AXF, but that's a very, very important thing when we're trying to go back and understand where an asset came from. Dynamically tunable lifecycle policies and SLAs, and this is something I'm going to loop back to again later on in the presentation, because I think this is a real important thing that we should all be looking at when we're trying to decide what types of architectures, what types of deployments we're going to use for the long-term protection and preservation of our file-based assets. And this really gives you back control of that capability. Content-aware integration with the media center tools and devices. I think earlier presentation from Avid talked about sort of the Avid ecosystem and this enterprise bus that they leverage there as well. But there's hundreds, if not thousands, of other tools that are out there as well. So having that connectivity and plug-and-play integration with all of those, so that when your journalist, producer, film production, color correction person, your VFX person, log into whatever tools that they use today, they have access to all of the assets across the entire enterprise. Automated health checks, automatic storage technology migrations, all of those nice technology things that happen behind the scenes. This is becoming a more and more important one, advanced analytics and the capabilities for deep asset intelligence as well. Being able to even leverage plug-in infrastructures for machine learning and metadata mining and things like that as well. And then again, the idea behind open standards base to protect against vendor lock-in, and again, that's something that we leverage with AXF. So what does that all boil down to? Essentially, you have all of these different devices and tools that create or consume content in your environments. You have a bunch of people that surround that interact with it, journalists, creative people, producers, investigators, detectives, whatever they happen to be. And that might be happening at one facility or a bunch of facilities distributed around the globe. You have a bunch of different tools and applications that those people leverage day to day. So there might be media asset management solutions, curation, preservation, analytics, metadata mining, BPM and workflow type tools, all of these different tools and platforms and interfaces that people use. And essentially, this is where content storage management sits. So again, think of it as an abstraction layer plugged into all of those different topologies of storage across all of these different technologies, whether it's on-prem, disk or tape, private cloud, as some other speakers alluded to today, public cloud object storage, public cloud archive storage, and then essentially being able to also do bulk data imports and bulk data exports to be able to move these huge volumes of data in and out of these cloud environments as well. And essentially all of those devices, all of those tools up along the top have access to all of the content no matter where it's stored across any of those different tiers of storage. And you have essentially full control over the SLAs and what you want each asset to do in those environments as well. Okay, so when we're looking at the cloud at massive scale, let's go back to our calculations here again. So now what I've done is I've just extended this out. So instead of actually storing to a data tape drive that happens to have a nice fiber channel cable inside your environment, we're talking about LAN, local networks, as well as wide area networks at different latency levels, different size pipes, and essentially looking at the same chart. So essentially I go from 1 gigabit LAN to 100 megabit WAN, 1 gig and 10 gig WAN connections. And you'll see that actually these numbers are looking better than the data tape technologies I looked at before. So essentially uncompressed 4K across a low to medium latency 10 gig network is about real time. So that's actually pretty good, and you've seen some speakers talk about multi-10 gig links. Of course, you could just put more pipes if you need to move data faster. But essentially now you're talking about potentially having pipes into and out of these environments, which could be quite effective in terms of throughput. Cost might be a different story. If you're within the United States, it tends to be very cost effective. If you're crossing borders, it starts to become a little bit more prohibitive. So, you know, this might be where you want to start using mezzanine formats to share with other locations around the globe, and using, you know, high resolution or uncompressed within local workflows more so than anything else. So now let's look at the cloud service providers. So I just picked some, not to offend anybody, of course, but I did include Google here since they're nice enough to host this event. I just pulled these numbers again off of the web this morning, so I think they, barring any unfortunate calculation errors, they should be quite relevant. So essentially these are comparative services, you know, a la Amazon S3, Google Nearline. You're talking about milliseconds-ish to your data. And again, if we look across the gamut of uncompressed 4K, essentially these are the cost for 1,000 hours per month. So you have to do the appropriate math for as long as you want these assets to survive in their entirety. And you'll see that these are quite expensive when you're looking at, you know, maybe a 50 or 100 year time horizon to be able to store and protect this data. If you've essentially lifted 100 petabytes of your most valuable assets and you've put them into a cloud service provider, you scale these numbers appropriately. And by no means are any of these cloud service providers telling or suggesting that you should store all of your assets forever in these resolutions in these particular storage services. So what did they do? There's other storage services, Amazon Glacier from AWS, and Oracle Archive Cloud, which is actually one of the least expensive long-term archive cloud solutions today. So now you're starting to look at the realm. Of course, there's trade-offs. Your access times are a little bit slow. They're still ranging in the, I think, hours, single-digit hours level. But for the bulk of your archive content, that's probably okay. It probably takes you much, much longer than that today to get somebody to go down to your Iron Mountain, pull back a film or a data tape or a USB hard drive or find the files that you're looking for. So again, this idea of having this content storage management, abstracting where the data is stored at what particular moment in time, and then leveraging the best cost to SLA profile that you can for the particular asset that you're concerned about, you could get down to, you know, essentially $5,000 a month to store 100 hours of uncompressed HD content, which is pretty compelling. But again, that's just the bare storage service, right? You need the capabilities to integrate with that, to tie into your devices, your platforms, your technologies. In this particular case, we have a service called Diva Cloud, which essentially is a content storage management as a service. It offers higher SLAs, so we do have all the integrations to the editing platforms and things like that. There is a cost premium, of course, but what we can do is we can put that in front of the very cheap archive cloud service, and you keep a portion of your content there that you have then access to in seconds of time. You have the capabilities integration with your devices, and you combine that with the archive cloud capabilities. So you sort of form a hybrid with tiers of storage in as a cloud service provider while you still have that capability of being able to maintain this content storage management capability as well. Now, when you're looking at the total cost of ownership of cloud implementations, of course, again, the raw storage doesn't tell the whole picture. You still need to buy all the different bits and pieces that connect all of this technology together. You buy your cloud connectors from every vendor that you're leveraging. You knock off a bunch of things. Obviously, you don't have to worry about infrastructure anymore. Networking now becomes maybe a more critical part than it was when you house the data center within your facility. Storage, all of that concern goes away. You don't have to worry about multiple copies and storage media. A lot of that's just check boxes in these cloud service environments. You do have recurring expenses. You still need staff. I think any cloud provider will share the view that you can't get rid of all of your experts, and in fact, it just changes the CVs of the people that you're looking at, right? You want people that know about networks, about UDP acceleration, about Cisco switches, firewalls, and things like that. There's some additive cost profiles here as well. Monthly storage, everything is per something per month. Data transfers, something per gigabyte per this, per transactions. Normally, if you look across all of the cloud service providers, they're not terribly different. Each one has their own little tricks and knobs that they turn on. So you really have to look at those kind of things when you're sizing out this capability before you're onboarding with a cloud service provider, because the way that you use, the way that you access your content could significantly change your cost profile. So it's not only about the data at rest charge, there's a bunch of surrounding transactional fees as well. So just be cognizant of that while you're doing your modeling. And then again, we'll talk about this being the glue, the content storage management software. So obviously it's not about on-prem licenses anymore. These are services that are available as part of a cloud suite to be able to gain you access to all of this capability while still leveraging the benefit of managing this data at scale in the cloud. So coming back is the big point here is it's not an either-or decision. You don't need to make a decision whether you move to the cloud or you don't move to the cloud. And unfortunately, some of the cloud providers really only have that black or white decision. But essentially, what you can do is if you choose to have a smaller, reduced scale on-prem footprint, maybe for everything that you're heavily transacting today, but everything from yesterday going backwards in time, you're happy to move off into the cloud. Maybe that's a mode of operation that you can do. And essentially what this lets you do is if you are looking across these different topologies and these different deployments, ultimately you then focus on what your SLAs and key business drivers are on a per asset basis. So essentially, what type of security do you want? You know, if it's a new release, new production, maybe you're happier keeping it on a disconnected array within your facility. Maybe not. Maybe you trust AWS's security team or Oracle's security team more than you do your own. The durability of the asset, how important is that asset? Is that your only copy? Do you need 5 copies of it? Access time, how quickly can you access it and how quickly do you need access to it? Transfer speeds, you know, obviously the pipes become a limiting factor, so if you do have smaller pipes, is transferring data at 5 times slower than real time going to break a workflow that you have in your environment? You need to look at that. Availability, if one of the cloud providers has an outage, if there's a network outage for your networking provider, how long can you suffer through that without it becoming a problem? And then, you know, ultimately the cost. And really, those are the characteristics you should be looking at. And again, if Oracle is providing a cloud service where we have monkeys chipping into stone tablets, and we're providing you the SLAs and the cost profiles, and we meet all of these SLAs, why would you care? Why should you care? Cloud-enabled CSM solutions empower you move in and out of the cloud. Again, we are all swinging. It's a nice fluid transition, certainly for IT infrastructures, for transactional workflows, the cloud makes sense. When you're talking about these environments at scale, when you're looking at signing on to something that might be hundreds of thousands of dollars a month and it's your crown jewels, you might just want to make sure that there's an exit strategy longer term. Not that you would ever execute on it, and maybe as the cost of storage comes down and the cost of these cloud services come down, competitiveness comes down, you still might want to make sure that you're mitigating the risk of having all of your eggs in a proverbial basket. And then, obviously, these content storage management solutions offer the flexibility to be able to dynamically manage the SLAs, essentially down to the per asset level. This asset is important to us. We need to match these costs, durability, resiliency, access time characteristics. Let's put that asset there. This one is lesser important, or this one is highly confidential. We need to put it here and nowhere else. All of those, now you essentially have that fine-tuning mechanism as well. So when we look at massive scale CSM-enabled deployments, again, we have all of these applications and tools up at the front end, and these could be, remote editors, remote producers. These don't have to be big, heavy applications. A lot of providers now have that. And essentially, if we look at the landscape, essentially you're looking at, high-performance flash storage being very expensive, but very, very quick, down through disk storage, which could be object stores, could be just NAS arrays or SAN arrays, through to archive storage, which is typically tape or optical. Then on the cloud side of things, you're looking at CSM storage being something differentiated with the application layer included as well, and then potentially as an archive cloud service as well. And the CSM solution sits in the middle and essentially gives you an SLA slider bar or an SLA dial that you can pick on an asset-by-asset basis. And as we learn more, predictive modeling, machine learning, AI, maybe you're actually going to let your metadata manage where these assets are at any particular moment in time. So you meet your business objectives by using information about the utilization of your assets as opposed to making guesses ad hoc. And then essentially this is really the stack as we look at it. So applications, devices, and tools, open APIs for accessibility, the storage abstraction and federation. Again, these are globally federated views of all of your assets across all of your environments, all of your different storage technologies. Dynamic SLAs defined in the software and fully controllable by you. And then again, across the whole gamut of storage types and topologies as well. That's it. So thank you very much.